This problem gives us a differential equation of first order, and it asks us to solve it. We have to find y in terms of x, and we're given that y is pi over 2 when x is 0. That will help us get rid of the constant when we eventually integrate this. Now, how do we integrate this? There are many techniques to integrate first-order differential equations, but this one is not so difficult. You can simply split the variables. And so what we do is we try to put all the y's on one side and all the x's on the other side. And we're going to do that by first dividing 1 plus x cubed from both sides to get that dy dx is equal to 2x squared, is it squared, over 1 plus x cubed times tangent y. Notice I wrote tangent y separately. What I'm going to do now is I'm going to divide tangent y from both sides and multiply both sides by dx. That way, what I'm left with is dy times 1 over tangent y is equal to 2x squared over 1 plus x cubed dx. Notice that. Now I can conveniently take the integral from both sides. But not yet. We have to rewrite tangent. Tangent we know is sine over cosine. Therefore 1 over tangent can be rewritten as, or actually let me write it here, as cosine of y over sine y dy, which we say then is equal to what we have to get from here. And this we're going to integrate as well as this using substitution, but in the next step. So let me just rewrite it as 2x squared over 1 plus x cubed times dx. Now, for this problem, we use substitution. U is equal to sine y. From that, it follows that du dy is equal to cosine y. Therefore, we say that dy is equal to du over cosine y. Follow me on this one. For this one, we also use substitution, but we use substitution 1 plus x cubed. I write it as u, but just so that it isn't confusing, you can write it as some other letter, let's say v, although that confuses you again because then we are dealing with homogeneous equations. So probably the letter z, and just we're not doing complex numbers, so just hold in there. And so dz dy, we're taking the derivative of z with respect to y, is 3x squared. Therefore dx, see, now I got confused. Dx, see, I confused myself because we're integrating dx on the side. I was in the y world from the side, sorry. So therefore dx is equal to dz over 3x squared. From this it follows that we can rewrite our integrals as the integral of cosine y over u, because we say that sine y is u, times dy, which we have here figured out is du over cosine y. Isn't this convenient? The cosine y's cancel. That is then equal to what we get here, 2x squared divided by what we have replaced with z times dx, but dx we said was dz over 3x squared. Just don't, this is by the side. And look at this, the x squareds cancel as well. From this, it therefore follows, we can do next row, that we're only actually integrating 1 over u with respect to u. And on this side, we're integrating, we pull the constant through, 1 over z with respect to z. Isn't that easy? Anybody can do that. So we get that the integral of 1 over u is obviously ln u, and so we put sine y back into u to get ln of sine y plus c, which is our arbitrary constant, is equal to 2/3 of what we get is the integral of this, which is again ln of z, and z is 1 plus x cubed, so let me just push this a little bit, ln of 1 plus x cubed. Oh, you can read that, it's okay. Now, what follows next from this is we have to rewrite c in terms of ln. And that isn't really an issue because you can just say that the ln of any constant is just an ln of another constant. So you can rewrite this as ln of sine y plus the ln of c, which is our constant, this is now our constant, is equal to 2/3 ln of 1 plus x cubed. The logarithmic property of ln of something plus ln of something else becoming ln of something times something. Of course, that makes no sense what I just said, but I rewrite this as ln of c times sine y, and this is all within the ln, is equal to ln, and we're using another logarithmic property here, ln of 1 plus x cubed to the power of 2/3, right? The power can be swung down if you wanted to. And now we can delog both sides of the equation to get c sine y is equal to 1 plus x cubed to the power of 2/3. We still need to find what the constant c is, and we're going to do that using the information we were given up here, that y is pi over 2 when x is 0. So now we plug in these values into here, and I'm gonna continue writing here. So we said that y is pi over 2, so we have to find c. So you just rewrite c. Y is pi over 2 is equal to, when x is 0, so it's equal to 1 plus 0 to the power of 2/3. Of course, sine of pi over 2, which is 90 degrees, sine of 90 degrees is simply 1, so we get that c is in fact 1, because 1 raised to the power of 2/3 is 1. And so you don't have to write anything for c, and you can conveniently rewrite the equation as sine of y is equal to 1 plus x cubed to the power of 2/3. But because the original problem, the only problem, asked us to find y in terms of x, we have to take the arc sine of both sides, and so the arc sine of sine y is simply y, and on this side we get the arc sine of what was on the right side, which is 1 plus x cubed to the power of 2/3. And that is our answer.